All right, so today we're going to talk a little bit about venting, gas appliances, some of the things to do, some of the things not to do, a little bit about code, just some things to watch out for. So looks like we got most people that have registered are here. If they're not, well, they miss out. So go ahead and get started. Rob Ellis with FIA. So I'm in our technical services division, and you guys get to listen to me for about the next 45 minutes or so. Right now, we have everybody muted. And if you've got some questions, you want to throw them into the chat window there, which you should find down along the bottom. There's a chat button. Go ahead and click on that. We'll get those answered. And then toward the end, we'll open it up if you've got some questions and make sure we get everything answered. All right. So without anything else, let's go ahead and get started. So really looking at venting do's and don'ts. What should we do? What should we not do? Those sort of things. We'll go ahead and I guess the first rule of venting is vent outside the building. It's always sort of a handy thing. This picture comes with sort of a funny backstory. It's an old picture going back before the days of smartphones and fax machines and email to a contractor who was basically calling into tech support, and he was having problems with his boiler. The conversation got into, what's your they finally got down to, hey, what's your draft over the fire? And he went out and came back and said, it's nothing. So they asked him to drill a hole 3 feet up. What's your draft over the fire? Still nothing. Finally asked him to take a picture, and this is the picture that got sent in. And initially installed, that sat there with no venting on it at all, hence why there was no draft over the fire. When they asked him to get a reading 3 feet above the boiler, he bought 3 feet of vent and drilled a hole in it and took his draft reading. So kind of a funny backstory to it, but the reality is, hey, make sure we're venting outside the building. There's a lot of codes that are going to pertain to venting, and it's important that you use the code that pertains to your area. So here in for us at FIA, we cover 5 states, and some of those are going to be under NFPA 54. Some are going to be under a modified NFPA 54 using like the Massachusetts Fuel Gas Code. New York City's got its own code. So always make sure that you're looking at what your local code. That at the end of the day will be the final determining factor of what you can and can't do venting wise. So let's talk about this right here. Authority having jurisdiction. At the end of the day, that is the final say. No matter what our manual says, no matter what the code says, you get down to this last person. It's generally your gas boiler or plumbing inspector will have the final say. And you're going to see that in most of your code books. That's who's going to get to be the final decision maker on what's going on. Right now, Massachusetts and New York City have modifications which are allowed under the rules of NFPA. And in New York City, they've gone out and eliminated plastic piping as a means of venting, and I should say PVC. And then in Massachusetts, they've recently voted to amend their version to eliminate PVC as a venting method. That is just waiting on the signature of the governor before that'll go into play. So even though the manufacturer is going to say something, doesn't matter who it is, the local jurisdiction has made a kind of a ruling on that. Talk a little bit about a direct vent appliance. This is there's a little misnomer on occasion. So basically, I get my combustion air from the outside and my exhaust to the outside. I have to do both to be a direct vent appliance. Leads to that question is, if my boiler or my furnace is on room air, am I still a direct vent appliance? And you are not a direct vent appliance at that point in time. So the rules are going to change. So if you install a furnace or a boiler and it allows for room air, and you do it that way, your exhaust rules will be different. You need to make sure that you follow those different rules as you're doing it. A fan assisted combustion appliance. So basically, we're using that fan to draw or force products through the combustion chamber or heat exchanger. It's a little bit different, and there's what we talk about it. Now, in our appliance categories, category 1, 2, 3, and 4, Most of what we talk about these days in a lot of the states is the category 4 appliance. That means we have positive vent pressure and we have flue temperatures that can cause us to condense. So these are important. That's generally we have lower flue gas temperatures than we might in a category 3, which is still a positive vent pressure, but now we have higher vent gas temperatures, and those are going to vent in different products. So it's always important we know what kind of category appliance we're looking at. And this is just kind of a nice chart that shows us there. So to the right-hand side of the chart, we're talking about those positive pressure. So we need a special vent system when we're positive pressure. It's got to be airtight, and that's important so that we can't force the products of combustion into the space. And that's why, so it's generally got some sort of gasketed or sealed fitting. If it's a plastic pipe, it's glued. If it's a gas system, it's got a gasket on it. When we get into our natural draft, our negative pressure, we're relying on the flue gas natural draft to pull it up through. We're not as concerned of getting those, products of combustion out of the pipe. And that's where you're going to get into some of your B vent. You might get into just your single wall galvanized pipes when you're talking about those types of appliances. Here's some don'ts. Just impressive. I see some smiles there. It's always good to put one of these pictures up. One is don't use, plastic piping on a, category 3 appliance that's going to melt it because of the higher temperatures. The one there with the kind of the flexible vent, I don't know, what do you guys think if you put a drain in, maybe in that belly there and just drained off any of the condensate that got in the way? But, certainly some impressive venting goes on at times, people will do. Apparently he didn't have a way to cut the vent material down. Let's talk about mechanical draft. So this is when we're using the fan to pull the flue gases through or push, either push or pull. It's basically an induced draft or a forced draft. If you have you've got a furnace, you got a direct vent furnace, and you don't take your air from the outside, you just move to a mechanical draft piece of equipment. So you're going to follow that because you're using a fan to either push or pull. In the case of most category 4 appliances, we're a forced draft, so we're pushing through, and so we want to look at that. All right, so we're going to push it through, but we're not taking our air from the outside, so we would follow the rules for a mechanical draft. And what's the difference? The difference is going to be our clearance to windows and doors. Because if we're drawing air from the room, the concern is we pull a negative inside the house. So if my house is really tight, I vent within a foot of the window, my window's open, I'm not getting my air from the outside. The concern becomes, can I pull air through the window for my furnace or boiler and basically draw the combustion back into the house? Kind of part of that ruling there. All right. And there's what you're going to look at. You're going to look at your manufacturer's instructions. You're going to look at what NFPA says to you for the clearances to the space, and then you're going to go to your local jurisdiction. So you might even have as we'll see it in different towns are going to have different rules that they're going to enforce. So just kind of follow that down as you're deciding how you're going to vent your piece of equipment. So here we talk about that mechanical draft venting system. Other than direct vent, terminate at least 4 feet below, 4 feet horizontal from that door or window. If that's direct vent, that's 12 inches. So there is definitely a difference of which way you're going to do it. So just definitely keep that in mind. 12.93, here it is. It tells us we can be that 1 foot away. So there you've got somebody venting, they're a foot away from what they need to do. But the next step is, just because it says you can, maybe you shouldn't. Should you be a foot away from somebody's kitchen window and your flue gases are going to blow across that kitchen window? I mean, you're going to get some condensing on it, stuff like that. Can lead to customer complaints and those sort of stuff. So it's a technically code compliant installation. Definitely some things to think about in how we're venting. Plastic piping. Important rule, kind of an important note here. When plastic piping is approved by a boiler or furnace manufacturer, the note is going to say, follow the appliance manufacturer's installation instructions. So if Lochinvar says you can use PVC or CPVC, the code says you have to do what's in the appliance manual, the manufacturer's instructions. So there's a little bit of different language here as we look at a different type of plastic venting. When we're gluing, always make sure we look for condensate dripping from the PVC vent, because if condensate's dripping out, pretty good chance we're getting flue gases. Right here, special gas vents. So this covers your polypropylene and stainless steel. But what the code now tells us is we're going to follow that gas vent manufacturer's instructions. So that becomes important. We're no longer saying, hey, what did the boiler or furnace manufacturer tell me I should do? Now we're saying, hey, what did Centrotherm or what did Duravent or what did Fasten Seal or whoever it is tell me I should do with my venting? So it's kind of important that you make that distinction as to where you're going. Appliance adapters are important. I'm going to switch over here for a moment because I've got one sitting right here on the bench with me. Jump this over here. And we are going to see if I do this right without crashing. All right, so we're looking at the back end of a Giannone style heat exchanger. And I use this one here when I want to talk about appliance adapters. A little hard to see, my lighting's not great. But right in here, there is a gasket, okay? So when you're attaching a special gas vent to it, it's important that we have the correct adapter. Whether it's stainless steel or polypropylene, that becomes important. There are two styles of polypropylene adapters. Right here, we see the gasketed style. So this would be if we were going into a non-gasketed adapter. So if I put this one in here, I now have a gasket on a gasket. We don't want to do that. It's going to create a situation where we can leak. So in this case, I'm going to get a non-gasketed appliance adapter. And that's going to drive into the back. I'm then going to tighten up my band clamp. And now I can take the rest of my special gas vent in here, is how that's going to go in there. All right. So we'll go back to a little bit of, hopefully that made sense there. Now let's jump back into, look at some more of those PowerPoint stuff, the really boring stuff. All right. So that's the importance of appliance adapters. This one here, you see that they didn't use an appliance adapter, and they've got a spot where we get leakage of flue gas right here. So it's really important that appliance adapters are used on these. How about mixing systems? You don't mix the systems. If you go stainless, you stay stainless. If you go CPVC, you stay CPVC here. In this case, this is, CPVC into stainless steel, and then it's kind of just gooped up with some RTV sealant. That's not going to be a good seal. You have a potential for a failure point here, and that's going to lead to, potential carbon monoxide leaking into the space. All right, so as we get into vent lengths, we talk about those. Everything's going to give you a maximum vent length for the boiler. Always make sure that you're talking about total equivalent length, and that means you're going to include your 90s, okay? So you talk about 100 feet. Those are equivalent lengths. So in this case, if I have 50 feet of PVC, CPVC, and I have 7 90s, that gives me 85 feet of TEL, or total equivalent length. So it's really important that we don't exceed that and that we always count our 90s. Unbalanced lengths. So can my exhaust be longer than my intake? Most of your boilers are moving in that direction, but it's on a manufacturer by manufacturer basis. So a lot of times you can have 2 manufacturers that are going to use the same gas train. They're going to use the same heat exchanger. They're going to use the same fan and everything else, but they're going to have different venting rules. And the venting rules go into the manufacturer has to have tested it. They have to test it, and then they have to submit it, and then they can be listed. So it may be the fact that that manufacturer did not test that configuration. We see most of the boiler manufacturers, though, furnace manufacturers, are allowing you to take that sidewall air and then run your venting up through the roof. So utilizing an existing chimney, something along those lines. A lot of time it is using those flexible liners down a chimney. Uh, to me, I like the sidewall air intake and the roof exhaust. Eliminates a ton of issues. There's no chance of flue gas recirculation. I mean, I guess you could. You'd have to work hard at it, but generally those things are going to go away. We get a little balance on our flue. We get some natural buoyancy to kind of help it along the way. So vent terminations, again, those are going to be manufacturer specific vent terminations as to how they go. One thing that's really kind of important is a manufacturer has to approve a termination kit in order for it to be listed with the appliance. So it's definitely something of looking at, hey, what does my manufacturer approve that I'm using before I use it? What's interesting is a lot of times is the termination kits could be made by the same different supplier. None of your boiler and vent manufacturers, or sorry, boiler or furnace manufacturers are generally making termination kits. They're sourcing them. But it just does become important in that listed and approved method that termination is listed in the manual. So definitely keep an eye out for that. On occasion, I've had an inspector look for that information from the contractor and make sure that that is an approved termination. Gas meters. See this a lot. Okay, don't terminate closer than 4 feet horizontally from any electric gas regulator, any of that sort of stuff. And it's really looking at the condensate. So as you look at it, the rule of thumb should be, can the condensate from this product, this exhaust, land on my vent, land on my regulator, vent, land on my meter, whatever it is. Obviously, condensing the condensate in the flue products, it's corrosive. It's acidic, so it can do damage to it. It can cause it to corrode. If we get a gas meter wet, bad things can happen there. The gas vents themselves get obstructed with ice, so definitely make sure those aren't causing an issue. Especially about this one here, and this is a cheap picture here. Here's what the manual says, and here's what they've got in the field. It's not bad at all. It looks pretty good. If we step back a little bit, what do we have? We're tucked in here behind the bush, a little bit behind the bush. We're going to get flue gas recirculation. What could we have done? Well, in this boiler manufacturer's world, snorkeling of the vent up to 60 inches is permitted. So if we were to bring those up, get them up over the bushes, we're going to be out from behind the bush. And I don't always have to take my intake up. Get my exhaust out of there so it's not recirculating. Now, little devil's advocate, you got to watch out because that looks like a window that's right there in the background. So sometimes we got to watch and make sure that it doesn't create. And it's tough sometimes getting some of these venting locations in there. Probably selecting venting locations, one of the toughest things on a condensing product installation. This one here, really not a lot you could do with this. And the contractor who ended up on this on a service call, he didn't install it. In fact, he wouldn't let me take any pictures when he was standing anywhere nearby because he was afraid I'd blackmail him with the pictures later. It is absolutely the truth. I certainly would have. So interesting story, in the original boiler failed that was in here. All sorts of problems. The homeowner couldn't figure out why. So they had a friend of a friend come out and put a new boiler in. Any ideas why that original boiler might have failed other than the fact that it's sitting there recirculating all day long? So on the level of what's wrong with this, it's probably easier to say what's right. There's a lot of things. One of them is they reuse the existing venting, and it was a manual say corrosion or leakage, corrosion, or other deficiencies. I'm going to say that vent probably should have been replaced based on what the manual tells us. Then we get into the fact that we're in a corner, under a window, by an air conditioner, vented wrong. So they had a 100% get it wrong rate on that venting right there. And we run into a lot of this out there. Just bad venting. Ask about this one. What do you see as you look at that picture? Other than it's a nice view of the Atlantic Ocean. So we come down, contractor did a stellar job actually looking at where's the wind in this location. They got it into the best protected location you could. When they put it in the house, they really did a nice job. I was out on this installation. It was a great venting install. They couldn't come around the front because they had bushes in the front, but I really got some protection from that wind, the prevailing wind that's going to come across here. The only thing that was missed is the sprinkler system that was here. And when they ran the sprinklers and made domestic hot water at the same time, they had a sprinkler that was broken here, and it was spraying, oops, right into that air intake. No fault of the contractor at all. It was a great install, but definitely something that when they were out there for now some service calls, they found it pretty quickly because they found a lot of water inside the air intake. But definitely just things that happen. Great install. Darn landscapers got them. Let's talk about some venting issues. Gratuitous, everybody not social distancing in a hot tub, and it's probably teasing everybody with that right there. Let's talk about noise. Short vent runs, you get fan and combustion noise, and it's directional. So when you put your venting on and your air intake, don't aim them at the hot tub. Don't aim it at the picnic bench, things like that. A lot of times the customers might complain about noise, and a 45-degree change in the angle of that vent changes all the noise. We see it a lot down in the Brookline, Cambridge area where the houses are really close together. And there's some of you guys here that are down in the New York City area. It's the same thing for you guys. Think about where you're aiming that vent when you have those houses in close proximity. And a lot of times just changing the angle of it solves a noise issue. Let's talk about some other venting issues. How about hard starts and combustion issues can result from over length venting? Sometimes when we come right off the unit with a couple of fittings, we can sometimes make it a little more difficult for the venting to kind of get started, okay, for that draft to go. And sometimes that causes us just a little bit of blowback. So in this case, not bad. It's just, best one I could bring up for this, but it's a 45 into a 45 into a 45 into a 45. I've seen these when they go 90, 90, 90, street 90 type of thing. So try and give it a little bit of run, a little bit of space before you kind of cram it back in there. That's avoiding those compound fittings. Some of your appliances out there actually will specifically tell you not to use compound fittings as you're going through there. This one here, there's some venting issues. Be a whole lot of issues here. So I got my intake, I got my exhaust. We have probably figured out a way to stop a train, and that is going to be by dumping flue gas right on top of it. Corrosive flue gas on a copper condenser is going to be good business for the HVAC contractor who gets to sell a new condenser down the road. But we're in a corner behind these things. We're going to have flue gas recirculation. Flue gas recirculation is going to lead to things like flame loss while running, could lead to flame failure ignition. But the challenge for the service contractor in this is if I'm recirculating my flue gases and my boiler shuts down, and I go out there to service it, and this thing is out in a flame loss while running status, and it's been off for a little while, my flue gases have cleared out. And when I hit the reset button, what happens? It takes right off. So then you get into the next thing of spin the wheel of parts and start trying to place parts in there. And we had a situation we were involved in a couple of years back, and they were about $4,000 into repairs, and it was basically this issue: recirculation of flue gases. Every time they'd get there, hit the reset button, it would work. Started changing parts, and in their case, their exhaust and intake was behind a bush. So sometimes take a look at that venting. Actually, in my mind, you should take a look at the venting every time you set foot on the property, no matter what you're there for with the boiler. Just a PM, trouble call, whatever it is, go look at that venting first. This one here, we've seen dryer sheets and chemicals within the detergents and everything else in the drying process really being drawn back in to the boiler, and those are things that should not be drawn into the air intakes of boilers and furnaces. So look for your proximity to a dryer vent. Aesthetic venting issues, kind of mentioned this a little early on. Looking at the vent blowing across somebody's window. In this case, this is a condominium project down near the ocean, and people on their balconies, this is what they were seeing up above looking down. But this blows right across another balcony here. So is it technically correct per code, per the manual? Absolutely. Did it lead to upset homeowners or condo owners? Absolutely. So, and then it had to get moved later. And now what do you do in a finished building? So kind of look around, see where it's going to go. It's definitely a kind of a don't right there. Anybody got any questions? Let me just go make it so that you can unmute yourself if you want to add something. There you go. So if you guys want to unmute yourself, if you got a question, now's your time. Nothing? Ah, it's quiet today. Everybody's tired of being home. So I did have one come in. Somebody's asking, are there appliances that don't require vent adapters? And yes, there are. And you're seeing more and more appliances that are going to have on them a polypropylene multi-adapter. And in those, you can use either the PVC, the CPVC, stainless steel, or your polypropylene. Seeing more of those. And it's stepped gasketing inside of there. So it's got room for all of them. And then you tighten them up. So Josh here, any tips on venting through a chimney kit? So a lot of it's going to be your preference as to whether you're going to pull down through or pull up. When you're using a flexible liner, they create more restriction. So your TEL that's available to you is going to change. And usually a flexible liner is a 2-to-1 ratio. So if I'm allowed 100 TEL, I'm only going to get 50 feet of venting that I'll be allowed to use on there. Now, most manufacturers, and they'll publish it, they'll show it, you can increase the size of that vent adapter, or I'm sorry, that vent length. So if I had a 3 inch and I go to 4 inch, a lot of times I can get my full 100 feet back. So definitely something to look at there. The other one would be minimum vent lengths. So you think about this, these boilers and furnaces are generally designed with maybe up to 100 feet TEL each way. The more vent we can get on there, the better it's going to be. So those are things that we want to look at. And when we hang them on the wall, let's see, I think you guys can see this over here. So I got a direct vent condensing water heater here. Let me switch over so you guys can. There we go. You guys don't want to look at that. I know you guys are all sitting there going, we want to look at you some more. So boom, here you go. Make sure you guys can see it over there. There we go. So right here, this is a condensing tankless water heater. So what happens is we mount these on the wall, the great space savers, and then we vent right out like that. We really kind of want to avoid that scenario if we can. And so if we look at it from the plumber's viewpoint, what's important to a plumber? My pipes look good. If you went to a plumber and said, man, I really want you to use some 45s, run this kind of at an angle, they're going to tell you no, because everything looks the way it should, proper pitch, good stuff. But on these, say I got a ceiling height right here, and I go right out there. I might want to take these and go over a bay. I can throw a 90 on, I get a little distance, little piece of straight pipe. Then maybe I can 90 it up into the bay, and then I can go out. But I can get a 90, I can get some pipe, get another 90, and I can get out there. Now all of a sudden, instead of maybe only having 7 feet of venting, I'm up into 20 feet of venting. So certainly things to look at. Russ is asking, can we vent under a wooden deck? So in general rules, no. And that's if I got a 10-foot deck, I can't be under it. I'm just not going to be able to get my venting out of there. You can vent under an overhang, and generally an overhang is considered something about 12 to 18 inches of space sticking out there. So that's what we're going to do and stuff like that. Bill's asking about Centrotherm, flexible pipe. Definitely that flexible pipe down through the through the chimney is definitely something that you can use in there. Now, when you're using any of the vent systems, the vent system that you start with is a vent system that you finish with. So in the past, I've seen where people say, hey, I want to use the flexible polypropylene pipe and I want to run PVC over to it because the PVC is less money. But you can't do that. That's not allowed. It's you can't mix vent systems once you're running them. So it's definitely something else to kind of look out for. So a lot of things to look out for. Definitely take a look at what you're doing. Um, so I see Bruce has got this. Many manufacturers can let you vent under a deck if you can maintain clearances and the deck is not enclosed. A lot of that time, you're also going to get into what are the different codes that are adopted. And I think Bruce is out of Maine, which is, I believe, the uniform mechanical code up there. So they're going to follow their ruling up there, plus the manufacturers. So again, that falls into what is the local, what is the manufacturer. Anybody else talk about? Anthony asking, can you use Centrotherm for the exhaust and PVC for the intake? You absolutely can. So the states that have, or municipalities that have said, hey, you can't use PVC vent anymore, they still allow PVC intake. Um, and it's a different, seminar we put on, we talk about Centrotherm, but they actually make a specific adapter for that exact scenario that allows you to run a PVC exhaust, a Centrotherm intake, and then adapt to the manufacturer's specific termination kit. So they do create something for that. So in answer to your question, Anthony, yes, you can mix Centrotherm exhaust, PVC intake. Does that answer the questions everybody's got? Anybody got anything else they want to jump in there with? I think we'll be doing Centrotherm a little later this week. George Carey will be running us through the product. So I send out after this one, going to send everybody an email with some resources, everything else. In there, we'll have kind of a link to that Centrotherm polypropylene course that we're going to have. So if nobody's got any other questions, I know it was a little short today, but really can't stretch this out too much. Really start talking about the same thing over and over again. So if nobody's got anything else, we can go ahead and just shut down the meeting and, basically thank you guys all for taking the time out today. I know it's a beautiful day outside and we should all be laying out and getting a suntan since we're all forced to be at home. But it looks like Bill, looks like you're in the office there today, working away. So again, everybody, thanks for joining in, and if you got any other questions, go ahead and just shoot me an email and we'll get back to you on them. All right. So thank you guys much.